Okay, welcome to, this is page 5 of 1.4. We have a cool little process going here. This is actually called the decomposition of functions. The composition of functions is what we were doing back here when we're finding f of g. We're turning two factories, I have a diagram of that here. We're turning two factories into a new factory. We go through we go through a factory, we put the result through another factory, and then we build the tree. In ELF language, if you've seen my discussion about Keebler's ELF factory, I've got a video on that as supplemental material, or if you're in class, I certainly go through that. We've got a factory here that is taking ones and subtracting x's, and then the thing that drives into it, and then it cubes. But that's all happening within one tree, within one factory. And what we'd rather have, and this is a big part of second semester calculus, what we would rather have is we'd rather have h of x split into two different trees, so it's f of g of x, which pictorially looks like this. I want to send x into here, and that factory is called g. I want the result of that to go into h, not h, into f. And when it comes out, I want it then to be 1 minus x cubed. I want to do part of the job inside of g first, and then the rest of the job in f. And it's all about order of operations. So g of x is going to do the first thing that happens, so I think it's pretty clear I might call g of x 1 minus x here. So if I put x into g and get 1 minus x, all that's left is just to cube the result. So f of x is not 1 minus x cubed. F of x just has to take the thing that comes to it and cube it. It takes this thing that comes in there and cubes it, and that's what f does. Okay, so pretty straightforward, and there's just one thing going on, or just two steps to the process. For instance, g of x, what happens first? We take x, the thing that comes in, and subtract it from 9. What is left for f, our outside function, to do? Oh, we just have to take the thing, which isn't 9 minus x, the thing is just x, and take the square root of it. Okay? Now, they say there's many correct answers. There are a number for this one, and I'm going to illustrate that a couple different ways. So here's what we could do. We could say g of x is, let's let g of x be 5 times x plus 2. Then what is left for x? Well, we have to put that thing underneath 4, but we still haven't squared the thing. There's a good answer. How about this one? How about we let g do most of the work, and we say, well, g, how about g is 5 times x? I mean, g has to be 5 times x, and then plus 2, but how about we square it as well? Then f of x just has to take that thing and put it under 4. And not really fair to g, the workers in factory g, they have to multiply by 5, we have to add 2, we're squaring, and you just have to put the thing that we make underneath 4? Holy smokes, we're doing a lot of work. I don't like that very much. How about we do this instead? We're willing to take the thing and multiply it by 5. We're going to pass that on to you. You have to put 4 over the thing coming in is just the thing, x. You still have to add 2 to it, and you still have to square it. I think probably, this isn't really a 3-part problem, but if I have 3 solutions here, I think probably the most logical answer to that is either A or B for it. But C's answer, this is fine. And sneaky here, the key to this, I would not know how to do this if these weren't a match. And you'll see in 77 you can use this as a model. I'm going to have g of x take the thing and add 3. So then f of x just has to take the thing that comes into it, whatever comes in there, take it to the 3/2 and take 4 times it to the 1/2. And as crazy as that is, and I mentioned earlier, this actually is important algebra for us in some calculus problems. There aren't a whole lot of algebra things that we would need to do this with, but in some calculus things it is important. All right, that should be a pretty quick section for you, and we will move on to page 6 shortly. Let me know.